Okay, so we're doing absolute value functions today, and we're going to do a combination puzzle, the first one, and we're given the function of negative 1/2 absolute x minus 1. Well, when I see this particular situation, I go think about my transformation, and I know that when this minus 1 is on the x inside, it means it's going to shift it to the right, not the left. It's going to go to the right by 1. So I know that there's going to be a shift to the right by 1 unit. This negative here tells me it's on the outside of the function, so that means it's going to be, remember our parabolas, this was our regular one, was negative and upside down, which means it was a reflection over the x-axis, not the y-axis. There's no up or down shift. That would be a value out here. And then the last thing though is that 1/2. This 1/2 is on the outside of the function. It's like our a value. And so that means there is a vertical stretch by a factor of 1/2. There is no horizontal stretch. So there's 3 transformations. Okay, and so now I also want to sketch this. I'm going to make myself a graph. I know it's going downwards. And so what's happened is I know that my base function was here, and I knew it goes to the right one, so it's going to be here at 1, at 1, 0. And I know here is originally going downwards because the negative, but this 1, 1, go over 1 down 1, this 1 over 1 down 2, it's going to go by a factor of half, so it's actually going to be here, going half more. So this value is going to be 2, 2, and negative a half. This one here is going to be, if that, well, it's not to scale, this is going to be over here, over 1, down a half. So this is going to be 0, negative 1/2. And so this is the one here that needs to be tidied up a little bit more. So this goes out here, and so I go over 1, down a half, so this is the point 2, comma, negative 1/2. I could, if I put 2 in there, just to make sure, I get 2 minus 1 is 1 times absolute value of 1 is 1 times negative a half. I can check these values to make sure that they are good. And so my pivot point is 1, 0. My x-intercept is 1, 0. My y-intercept conveniently ended up being 0, 1/2 negative. The domain, well, it can be all reals. I could put any number in here and it's going to work out. But the range, however, is going to be all these values smaller than or equal to 0. All right, so we've done our function notation. The problem solving algebraic fluency, f at 3 minus, well, if I plug this value 3t minus 8 into my function, I know that this is my x value, 3t minus 8 minus 1 equals negative 1/2, and I get 3t, taking out the parentheses, minus 8 minus 1 is minus 9, and this is the end. That's as simplified as I can. I cannot take this off, the absolute value sign off. Moving to f at minus 5, well, let's try f at minus 5. It's going to be negative a half, absolute value of minus 5 minus 1, which is negative a half. This is negative 6, negative a half. Absolute value of negative 6 is a positive 6, because that's what it does. It makes it positive, and so it ends up being a negative 3 value. So this is negative 3. So when we deal with the absolute value function, the final answer can be negative. It's just when you apply the job of the absolute value, that makes it positive, like this negative 6 becomes positive 6. And finally, this last one here, I'm not even going to try and do it algebraically. I'm going to my graph. I can see the y value is 0. That means x is equal to 1. All right, and so our function notation. Well, when I do this, I know that inside the p, the function was an x minus 1. I know in front of the function is minus 1/2. There is nothing outside on this side, so I'm going to leave it blank. If I want to check it, go over to Desmos. This time I know that f was equal to minus 1, and it was negative 0.5, which is the graph that I got. And if I do this one, p at x minus 1 and negative 0.5, again, I can see that that is a correct representation of the function notation idea. And then finally, the last one to check, f at r. So this is f of r of negative 1. Well, I'm going to take this negative 1 and plug it in, so it's going to be f at, I plug the negative 1 into here, negative 1 minus 7 over negative 1 plus 3, which is negative 8 over 2, which is f at negative 4. Here's f. That means it's going to be negative 1/2, negative 4 minus 1, which is negative 1/2, negative 5. Well, negative 5 becomes a positive 5 times a positive 5, and that ends up being negative 5 over 2 is the final answer for that. So again, we use our graph, use the equation and the transformations to find our key features, and we put it all together.